Hey, it's Amy, and I wanted to show you what I'm doing to practice a little bit for my med math and my NCLEX. NCLEX is coming up. I still do not have my ATT, so I would tell you if I had it, but I wouldn't tell you when my test was. But I don't have it yet because this is a weekend. And anyway, there are ratio methods, there are dimensional analysis methods. I prefer the formula method. I'm going to show you how to do tablets and pills. I'm going to show you how to do like a liquid. I'm going to show you how to do IV calculations where you have to do a calculation to do a drip factor. And then I'm going to show you like if you have to do a medication. And everybody, I know some people say, oh, but IV pumps do it all for me. I don't have to do anything. That's not always the case. Our facility, we have to give albumin by a drip factor. Yeah, the IV pump does not do albumin for us. We have to do it by gravity. So that, you need to know how to do these things. Even though you may not do them very often, you do know how. Need to know how. So let's do a tablet or a pill. Furosemide. You need to know your generic names. Make sure you know these. 60 milligram order, PO every day. Now, your order would not just say every day. I mean, it might say every morning. I mean, it could say a lot of different things, but these are basic orders just to get through a med math problem. These may or may not be actual orders that you would see. Supply 40 milligram tablets. So you have tablets that are 40 milligrams each, so one tablet is 40 milligrams. You have an order that needs to give 60 milligrams PO every day. And, you know, one dose is 60 milligrams. So, and I've already done all the calculations because I didn't want to have to take the time to do them on the calculator. So I've already done them. I'm just going to show you. The formula method is desire over have times supply. Supply is your tabs or your mLs, or it's your volume. It's like if you have 1 tablet, 2 tablets, 5 mLs, 3 mLs, that's what your supply is going to be. This right here is going to be your mLs, your tablets. Your have is your milligrams that these equal. So 1 tablet is 40 milligrams. So I have 40 milligrams in my supply of tablets. Does that make sense? I hope that makes sense. Your order is your desire. That's what you want to have. Which would be, like I said, your order. So you would take 60 milligrams, divide by 40 milligrams times 1 tablet. Now I put that 1 there. I want that 1 because if I don't have anything there, I don't know how many I have. But if I put that 1 there, I know it's every single tablet has 40 milligrams. So 40 milligram tablets, there's 1 tablet for every 40 milligrams. So you take milligrams and milligrams, cancel each other. So you're looking for how many tabs you're going to give. 60 divided by 40 is 1.5. So you would give 1.5 tablets. And you can kind of see that in this problem, but you can't always. Like if you had a 10 and a 5 there, you would know that 5 goes into 10 twice, and then you would give 2. But, you know, I mean, you can figure that out pretty easily, but you can't always figure it out when it gets down to 6.25 milligrams and all that. It gets a little bit more difficult. All right, let's go to liquid. Okay, so right here, let's ignore this one down here. So right here you have digoxin order. You need 125 milligrams IV daily, and your supply is 250 per ml. So every 1 ml is 250 milligrams of digoxin in this problem. Okay, 1 ml is 250 milligrams. So you take your order or your desire, 120 milligrams, over your have, which is your 250 milligrams, because these will match, cross those off, times 1 ml. You want that number there, okay? So 120 divided by 250 is 0.48 times 1 is itself, so it's 0.48 0.48 mLs. That is your answer. If you have a number that does not have a whole number in front of it, in front of that point, in front of your decimal point, you don't have a whole number, you need to put a 0. Always have that 0. 0.5, 0.48, 0.66, whatever that is, always have that 0 in front of that. Otherwise, this might get missed and somebody's going to give them 48 milliliters of digoxin. I would hope nobody would do that, but you want that 0. Alright, this one here I've already filled in. I'm not even going to try to say that. Your order is 100 milligrams of IV daily. That's your order. Your supply is 125 milligrams per 2 mLs. Okay, so this is your supply, this is your have, this is your desire, right? Your supply is the milliliters or tablets, the milligrams, micrograms, grams, whatever this is here. That is your concentration of your medication. That is your have. And then your desire is always your order. This and this need to match. Milligram and milligram. If one of them is grams, then you need to convert it. You can convert it either way, but I think it's easier to convert. I don't know. You can convert it either way. You should still get the same answer. I usually just convert whichever number is easier. But milligrams, there's 1,000 milligrams for every gram and 1,000 micrograms for every milligram. So if you needed to convert this, you would go over 1, 2, 3. So it would be 0.1 grams or 100,000 micrograms. Yeah. So you would just move the decimal point 3 places, whichever way you need it to go. But these two, the milligrams, need to match. They have to match, okay? Because when you put the 100 milligrams over 125 milligrams, they need to cancel each other, so they have to match in order to do that. So you take 100 divided by your 125, that gives you 0.80, and then you multiply that by 2 mLs, which gives you your 1.6 mLs. That's your answer. So now we're going to go to IV calculations. Now this is your formula for IV calculations. Do not let it scare you. It is not that bad. I promise you, it is not that bad. Let's explain the difference between a micro drip and a macro drip. When you see micro means small, macro is large. Then you look at the numbers and think, well, this number is bigger, these numbers are smaller, so why are the small numbers macro and the big number micro? Because it doesn't have anything to do with the numbers as much as it is that a micro drip is a small drip. Micro drip is a small drip, small drop of fluid, IV fluid, whatever you're giving. Let's just say for this it's normal saline, because that's what this is, the problem is. So a micro drip of normal saline, every drop is small. So it takes 60, because GTT or GTTS is drop or drops. So it takes 60 drops to make a milliliter. Okay? Your macro drips or your macro drop, think of it as a macro drop, a large drop only takes 10, 15, or 20 drops to make a milliliter. That's the difference. It doesn't have to do with the numbers. Macro does not mean large number, means large drop or drip, which then means it takes less of them to make a milliliter, okay? You see a number, see a letters in here, a TF. What the heck is that? TF is your tubing factor. These numbers are your tubing factor. Don't ask me why. It's just these are the number of drops it takes to make a milliliter, and that is your tubing factor. So what you want to do is you take your number of milliliters to infuse times your tubing factor, which is one of these numbers. If it says a micro drip, automatically it's 60. If it's a macro, it could be either one of these three, and they should tell you which it is. You take the number of milliliters to infuse times your tubing factor, divide by the number of minutes to infuse. Minutes. Not hours, days, whatever. Minutes. Okay? So if it says per hour, your orders per hour, then it would automatically be 60. This would be 60. Do not put 1 hour and divide it by 1. You will get it wrong. It needs to be divided by the number of minutes. So if it's 1 hour, it's 60. There. Okay, right there, it would be the 60 minutes. So let's go to your order. You've got 500 milliliters of normal saline IV over 4 hours, from 12 to 1600, which is 4 p.m., or gives you 4 hours. Okay, and what do we need to do to convert this? We need to convert these 4 hours to minutes. That goes on the bottom. I always do this first because then I don't have to look at it anymore, and I know that's converted. Okay, so what you would do is you multiply your 4 times 60, and that gives you, let's go ahead and put it down here, 240 minutes. So 240 minutes is 4 hours because you're giving it from 12 to 4 over those 4 hours. Okay, let's do a micro drip. Remember, micro drip, think of it as a drop, small drop. Takes more small drops to make a milliliter than it does for large drops because they're bigger, so it takes less of them. So a micro drip or micro drop would be 60 drops per milliliter. So you take the number of milliliters to infuse. You want to infuse 500 milliliters of your normal saline over 4 hours. And you're using a micro drip set, which is 60 drops per milliliter. Milliliters will cancel out. So you have 500 times 60, which gives you 30,000 drops. That's a lot. Over 240 minutes. And then that goes equal down here to 125 drops per minute. That's basically almost a little bit more, give or take. I mean, a little bit more than 2 drops per second, because if you got 60 minutes and to get so that would be 120, yeah, that'd be 2 would give you 120, so that would be pretty close. I don't know if you could get a whole lot closer than that unless you sit there and count a minute, and it would take a lot of minutes to get that 125 before you got it exactly perfect. But like I said, albumin does have to be given. I don't remember if I said this in this video. I've done this video like 5 times already. But albumin we have to give by gravity. We can't do an IV pump. It's really, really thick. So we had to figure this out for the order. So this is how you do it. Number of milliliters to infuse times your tubing factor, which will be your number, over minutes. Number of minutes. So if it's 1 hour, don't put a 1. Don't do it. Put 60. I always do this part first, the 60 minutes. The minutes first. 240 minutes, 500 milliliters times 60 drops over 240 minutes, 30,000 over 240, which is going to give you 125 drops a minute. That's going to be a fun one to calculate, won't it? Alright, so let's go ahead and do it with a macro drip. And I'm going to say it one more time. Macro drip or macro drop. Think of that as drop. Macro drops, bigger drops to make a milliliter. They're bigger, so it takes less. And so we're going to do the 20. This is going to be the 20. And we're going to tell you to round to the whole number. If it does not tell you to round to the whole number, it should tell you what place. I've been told the NCLEX tells you. If it tells you to, I think it says it on their, yeah, it says it on their website too, like their thing where you can go in and see like what the test is like. It says it'll tell you to round to the whole number, round to the 10th place, you know, it'll tell you where to round. Because it's not fair to give you something that comes out to, and not tell you how far to go with it. And then and I've also read on there where it tells you if you want to round at the beginning, round at the end, like if you do the whole problem and just leave the numbers the way they are, because you know sometimes you get this long 0.663 or whatever, and it'll tell you where to round and when to round and how to round. So, which is good. So remember, you've got your number of milliliters to infuse times your tubing factor of 20 drops per milliliters. And remember, GTTS just means drops. And if you leave off the S, then it just means drop. GTT is drop. 500 milliliters times 20 drops per milliliter. Milliliters cancel out. You're still giving it over the 4 hours. Like I said, I always do this first, and I already did it back there, so I don't have to do it again. 240 minutes. You take your 500 times 20. And like I said, I've already done my math so that I didn't have to take time in the calculator, so I could get all of them done in a smaller amount of time. 500 times 20 is 10,000. 240 minutes. And then you take your 10,000 divided by 240, which gives you 41.66. 66, it tells you to round to the whole number. This is a 5 or above, so you go to 42 drops per minute. That's your answer. 42 drops per minute if it tells you to round to your whole number. If it told you to round to the first place, it would be 41.7. So, because the 6 is higher. Yeah. So you know how to round. If it's 5 or above, it goes up. If it's 4 or below, it goes down. So let's do a basic heparin drip. This problem right here freaks people out when they say units per hour and units and 25,000 units and 500 milliliters and oh my goodness, what are we doing and how do I do this? And it freaks people out. Don't let it freak you out. A basic calculation like this you can do in your formula method. Okay, remember what that is. It is desire over have times supply. Remember what supply is. Supply is this. It's the milliliter or tablet of your available. Okay? This is your have, and this is your desire. So you have, in your desire place, you have 1,000 units per hour. Okay? Your have, which goes under here, so your have goes under here. Your have is 25,000 units. And your supply is your 500 milliliters. I already had that. Alright, so your units cancel each other out. You take your 1,000, divide by, I don't think I did that, did I? Yeah, I didn't write that down. Your 1,000 divide by 25,000. Let me go ahead and do that real quick because I forgot to write that on my paper. I did it, but I forgot to write it on my paper. So 1,000, oops, divided by 25,000 is 0.04 times 500 milliliters. And don't forget your hour times 500, whoops, equals 20. milliliters per hour. Okay? Let me go over this one more time real quick. 1,000 units per hour. That's your desired, your order. 25,000 units. 25,000 units. Multiply by 500 mLs. See, we don't have tabs there, we have mLs. Earlier we had 2 mLs, but it's the same difference. It's still your supply. The concentration or the units is still your have, and this is your desire. So it's basically the same thing. 1,000 units per hour over 25,000 units. Units cancel each other. It's 0.04, don't forget that 0, times 500 milliliters equals 20 milliliters per hour. There are harder ones where you have to figure out your units, like it'll be 1,000 units per kilogram per hour or 18 units per kilogram per hour. So to do that, you would do like an 18 units per kilogram. So you would take your, I'll do it real quick, 18, say it was the 18 units per kilogram per hour. So you would take your 18 and convert, you would have to know how many, you would want it in pounds or kilograms. You would, if you have 18 units per kilograms per hour and then the patient weighs 150 pounds, okay, let's say they weigh 150 pounds and it's 18 units per kilogram per hour. So if you have 150 pounds, 150, I always say I like my weight better in kilograms because it's smaller. The number is smaller. So you have 150 divided by 2.2. 150 divided by 2.2 equals how many kilograms? It wasn't a good choice, but 68.18. 68.18 kilograms. So a 150 pound patient weighs 68.18 kilograms. If you have to figure out how many units 18 units per kilogram is, you would take that 68.18, multiply it by your 18 units, and then that would give you, and this is a weird number, you probably won't get a number exactly like this on your test, but in real life it's possible. Kilograms per hour. I mean, whoops, sorry. I was looking up the kilograms. Units. So basically, when they say they give you 1,000 units per hour, to figure that out, if they give you a question that says 18 units per kilograms per hour, and then your patient weighs 150 pounds, you need to transfer this 150, convert this 150 pounds by dividing 150 by 2.2, because remember, I always like my weight in kilograms because it's less. So 150 divided by 2.2 is the 68.18 kilograms. Multiply this by your 18 units, and that will give you how many you need. 1,227.24, or if they rounded down, it would be the 12.27 units per hour. And that would give you this number here. And then you just plug it into this, and then you go on with yourself. And that's how you would do that. There are a lot of people that do it by dimensional analysis, and I just feel like there's too many steps in that for me. I'd rather just say 18 units per kilogram. My patient's 150 pounds, means it's 68.18 kilograms. Multiply your 18 units per kilogram so that you know how many units per kilogram you give. You give 1,227 units in an hour, because you've converted your pounds to kilograms, and you've converted this, and that would give you your units per hour. Then you just take your units per hour and your 25,000 units times 500 mLs, and then it'll give you your answer. So that's how you do heparin. When you first see it, it's kind of confusing. It's a little scary, but to me, that's how I do it, and it makes sense to me. I hope it makes sense to you. I hope it helps somebody, and this video is getting long enough, so I'm going to go. See you guys later, and I hope you enjoy this video, and I hope it helps. Bye.